Good afternoon, folks. This is Anthony here. Welcome back. It's been a little bit since I had a video recording publicly. I'd been working on the network automation mini course, finishing that, teaching that, and as you can see here, we have all of the code from the course. So we're not covering any of this. The purpose of today is to go through the PyTest suite and testing overall. I've been getting some requests for doing types of testing within Python. Some people may not have a context as to the relevance of that, but in essence, the importance of testing is at a method or function level, or even a class level. You want to make sure that when you set up your package, if it is packaged, then you want to make sure that all your tests run accordingly. You want to make sure that everything you believe should work does work. There are situations where certain components of a script or of a package won't work on a certain Python version, won't work on a certain operating system. And because of that, it is important to have tests in place. In addition to that, it's also important to write tests to make sure that you're getting the output that you want to. Now, when you're looking at the output, you want to make sure you have positive and negative tests. And to do that, you need to specify whether it's a positive or negative test. The module that we're going to be using today in particular is PyTest, because overall it is a very good library to run unit tests on. And there are other options out there, but overall, PyTest is very popular. It's relatively straightforward and easy to use once you figure it out. And it can be highly useful when you start getting into developing more complex code. I want to start out with some simple examples, and then we can dig into a more specific use case, possibly with an API that was written in Flask. We could probably do a few other pieces here and there, but that's really what I want to focus on is PyTest. If we have time after that, since linting is in essence a part of testing, I think that we could definitely cover Flake 8. Flake 8 is a linter. We could also cover YAML lint if need be. But first, let's start with PyTest. Okay? So we'll start with a simple function, and we'll call that function addition. Within that function, we are going to pass the parameter of numbers. Okay? Numbers is expected to be a list. Within this, we will say return the sum of our numbers. Okay? And then we'll say addition, and our numbers list will be 2, 3, 4, 5. Run that. And we got 14. So in this case, you're probably thinking, well, this is just a very simple example of, a function. There's not really much complexity to this. And you are absolutely right. But let me ask you this question. What would happen if I were to put a string into this. I'm going to get an error, okay? Because you can't concatenate string and an integer. It's not allowed, okay? If you were to put in a different data type, so if you were to say 2, 3, 4, it's going to throw an error. These are the little things that we have to account for. The little things. Okay? So the question is, how do you test this in PyTest? Now, again, this is a very, very, very simple example of what tests will look like. Once we get into the more complex code to where you're not necessarily certain of what may be returned in a variable or an object, then that is where testing becomes very, very useful. So what I'm going to do is I'm going to turn this into a set of tests. First thing that you have to do with PyTest is you need to have a tests folder. Secondly, you need to have the word test at the beginning of the Python file. This is how PyTest identifies the files that will run tests on. And then within that, you also have to add to your functions, you have to add test before the function. Pretty simple, pretty straightforward. So now what we're going to do is we're going to say test underscore addition. And then we're going to have a couple tests here. First, we're going to say assert type numbers equals list. Secondly, we are going to say assert that type of X equals int for X in numbers. So this is, for some of those who do not know, this is a list comprehension. I've actually never put a list comprehension into an assert method, but we'll see if it works. And there's no return that you're doing unless you're trying to pass this into another test. So for now, we're just going to pass those in and make sure that we've accounted for all possible permutations. So we've accounted for the fact that all of the entries in the list, well, firstly, it has to be a list. Secondly, every entry in the list has to be an integer, right? And then let's add something else. Let's say that there's a limit to this, okay? Let's say that there's a limit to this. Let's say assert sum of all numbers is less than or equal to 1,000. Okay. So maybe we have a limitation on what we're allowed to put into there. Two, three, 4, 2, 3, 5, 6. Okay. And then let's see what happens if we run the tests. All right, so now this was intentional, but in essence, what we want to do is we have to have a fixture. So you can't have, in a normal Python script, you can just throw in some data globally and then pass that into a function. However, in this case, what we have to do is we have to return this as an object, or call this as a function to get the desired result. So we're gonna name this a function called numbers, right? And then this is going to be our parameters. And then at the top here, we're going to say pytest.fixture. Now, if we run this again, oh, I also need to import pytest as well. Import pytest. Run that one more time. There we go. We are now passing all of our assertions. All right. So now, if I were to change this to another number, actually, I'm not gonna do that. I think what I'm gonna do is I'm going to intentionally get a failure. So we're gonna say test edition fail numbers list, and it will pass in the same fixture. It will use that again. And then we're going to say the same thing, assert type numbers equals list. Now this is where we're going to add something. We're going to add something. So we're going to keep the same tests here, but what we're going to do is we're going to intentionally add in here a statement that says numbers dot append, and then we'll give a number of 400. Actually, no, we'll say 1,000, since that'll break our third case that we're going to put into here. Okay. Now we're going to run it. And here you go. We now have an error. Okay? So the question is, what if you were expecting that error? What if you were expecting that error? What if you're running a test where you want to make sure that there is an error actually being raised? Because there's times where an individual will write code and they'll say, oh, this should raise an error, but it never does. But so they never catch the problem of, basically changing or modifying something when they don't want to. And then that can become problematic. So what you do here is you type pytest mark xfail. Okay. Now it's going to give you several things here. You're going to say raises equals assertion error, because that's what's coming up here is an assertion error. What's going to happen is it's going to expect a failure. Okay, I'm going to run that again. There we go. Both tests have gone through. It's not red anymore. It expected the failure and it received the failure. Now, the next question is, what else would we like to do when we're running tests? Okay. So I'm going to give you an example. This is a great example. If you have a API post or a put request, within that post or put, you're going to want to make sure that the structure of it is correct, that it's X number of entries long, or that some of the values are of particular data types. Or, another thing could be that you expect a certain response code when you make the API call. Okay? So we are going to add another fixture here. We're going to say, firstly, we're going to say PyTest fixture. We're going to say def schema. We're going to return a schema. And we'll say ID is 123. IP is 192.168.50.51. We're going to say the port is 443. And let's see, what else could we put into here for a host. We'll say type is firewall. Okay. And then we are going to return another fixture here. And what this fixture is going to provide is some definitions of what is allowed in the data. Okay. So there's one thing that I'm going to add for now, just one thing. We're going to call it types. And it's just going to be a list, actually. So I'm going to say firewall is a type, switch is a type, router is a type, VPN is a type. Okay. And then we'll say def test API schema, pass in the schema. We're going to say, firstly, assert length of schema is equal to 4. Secondly, assert schema, we'll say assert type schema port equals int. Assert type schema. Oh, actually, there's one other fixture to add into here. Let's add the types. Okay. Type schema type in types. What else? What else? Here's another assertion you could do. Assert that we're going to do another list comprehension here. X not none for X in schema values. Oh, yeah, I need to remove that. Rerun this. Okay. So now we have another passing scenario. Now we're going to add one more failure scenario. And this one we're just going to say pass. And this one we're also going to say pass. And finally, we're going to have a failure scenario. Okay. We're going to copy and paste this whole thing, but we're going to make one very subtle modification. Right here. We're going to say schema. Oh, actually, I need to pass these in as well. Schema. We're going to add a new key value pair. Okay. We'll call this Network OS iOS. Now this assertion will fail. And there is our X failure. Okay. Technically, we could actually break these tests out even more if we wanted to. But in this case, I'm just putting these all together. So that gives you a pretty good understanding of, what to expect out of this. Now, if you're wondering, what exactly should I expect when, I'm running these tests? Where can I actually apply this? Again, it's going to come down to what you think could have a degree of variance. You should be testing everything possible if you can. There's going to be some obvious things within the code where you're like, of course, this value is going to be a constant or whatever. But I would say that one thing you want to do is a good example of testing would be making API tests. So when you make a get, you expect to receive a 200. When you make a post or a put and it's doing its thing, you expect to get a 201. If you make a delete, the delete is successful, it's a 204. If you do not get the desired response code, or if you get a specific bad response code like a 400 or 500, then that could either be a failed test or you could expect to fail the test. So, coming back to, for example, things like this. If your API schema is off, if you want to make sure your data types, your validation looks good, pretty much all of your assumptions are correct, then you want to make sure that works out. Now, one thing you could also run tests on is connecting to a network device. So you could assert that a session was successfully created. When you push a command, maybe you expect a specific response time. Maybe the responsiveness of the device is not up to par as to what you expect, and that can be something beneficial when you're trying this out. So, things like the telnet lib are very slow in how they process things. If you can test this, if you can test and basically assess to make sure that across all environments, this is the key, this is the big key. When you write these tests initially in your own environment, you're kind of already going to know what to expect because you're observing one particular permutation of what it is you're running. Some of the things that you might encounter is, for example, in a certain version of Python, that version of Python does not support a specific module. Okay? So there is a ability to do that. If you say pytest.mark.skipIf, okay, and it's going to give you several options. One of them being, let's say there's a library, GUIP or Django, whatever it may be. And Django is none in this case because we haven't imported Django. Then what's going to happen? Oh, and it wants me to specify a reason. There we go. So they all passed. I basically, none of those were skipped. None of those were skipped. We're still running all four. But if I change this to not none, which I don't really see a situation where that could happen, then it's going to skip it. Skipped. Okay? So there's going to be situations where maybe you're not allowed to install a specific Python module. In that case, you're going to have to skip the test. And honestly, if there's a certain module you cannot use, then either you have to rebuild, you have to re-engineer the code, or you're not going to be able to use it. So that's just something to think about. The skip if decorator is pretty useful. So now we've done unit tests. That's pretty much what PyTest is. But there are many other types of testing that we can implement in our small projects. There's a lot of different types of testing. We're not going to go into all of them. But the first thing that I wanted to cover is unit tests. Now what I want to cover is code formatting and best practice code writing. Now, when you're thinking formatting and best practice code writing, you're probably thinking, well, I don't really want to go through, doing all that. It seems very tedious. Rating PEP 8 standards and trying to figure out what the best way to format it is. Well, this is the thing. There are modules for both of these things. The first module is Black. Black will do the auto formatting for you. And the second one is Flake 8. Flake 8 is an option, of course. There's other options as well. But Flake 8 combines PEP 8 standards with something called PyFlakes. So you get a mix of two good things at the same time. Now, we're going to use both of these tools. And then there's one other tool that not a lot of people tend to have much of any exposure to. I'm actually pretty new to it myself, which is relating to security testing. So security testing really has to do with security vulnerabilities that can be in your code. And ultimately, for what we have here, there's not really too much that we have to worry about, but there's a couple things in here. So I'm going to start firstly with Black. Okay? All you have to do to get Black working is to just install pip install Black. And what you'll see in my make file here, that's the wrong one. What you'll see in the make file here is I have a linter, or excuse me, not linter. I have a formatter right here. Okay? And ultimately, after this does its magic, I have a log file, and it will send what the updates were to that log file. Now, if you want to see what this does, we are going to run all three of these at the same time. We're going to run Flake 8, YAMLint, and Black. Black is a formatter. Flake 8 is a linter. YAMLint is a YAML linter. So Flake8 does Python files, YAML does YAML files. What I'm going to do though, before I run this, is I'm going to add a few things into my code intentionally so you can see the magic that happens. Okay? So firstly, we are going to go into the main file, and we're just going to start randomly removing all this white space. And maybe we'll throw this down here too. Okay. And we'll do that. Now, there's a few things we can do. All right, save that. The next thing that we want to do is we're just going to throw some random variable in here. Or better yet, let's just do this. Finally, we're going to go to a YAML file, and we're going to change the YAML file. Save. All right, so now what I'm going to do is I'm going to run the make file that I have here, and I'm going to do prep test. Actually, no, I take it back. I'm not going to do the tests. I'm going to do prep no test because the test will fail that I have because I do not have my development environment up and running. So we're going to do prep no test. It will do the formatting, it'll do the linting, and it'll also do some cleanup. Okay, so we're going to say make prep no test. I'm going to run it. Okay, and we have a couple of things here. We had one reformat, and I know for a fact that's in here. Pretty sure it's in here. So you will see that this was reformatted, as was this. It's all reformatted. And for some reason we had a format issue in the app.py on line 22. Oh, yeah, you got to put the colon there. And then let's see what else we have. So, no, I didn't finish. That's the thing about the make files is if an error comes up, then it will stop, and it stopped because of the black formatting. So I'm going to do this one more time. Okay, so now we see here we have our reformatting complete, and now it completed Flake8, and it looks like there was a lint. The lint phase had an error. When the lint phase has an error, that means that there was something we have to take care of. So there you go. We have one error in total. And I'm going to work around that by going. So what we'll need to do is we're going to put this no QA here for now and exclude that code and run this again. And so it made it past Flake8, and then we got an error with YAML lint. But for some reason, it's not giving me the error that YAML lint is receiving. So let's cut this out for now. And let's run the make again. Maybe it'll give us our output instead. There we go. So this is what's supposed to be redirected. Not sure why it's not. I'll have to check on that. But you're going to see various things. and I got a lot here actually. So these are all warnings except for an error. I'm going to ignore the warnings for now, and we're going to go to this error on line 55. This is line 55 where we decided to screw this up. It says syntax error, expected block end but found question mark. So that's obviously not too apparent when you first look at it, but once you see the code, you're going to see it yourself and you're going to say, okay, well, I obviously have to fix that. It's pretty apparent. And then we also have another one in lab device validators. What's the error? 38, line 38. Oh, we have 2 white spaces. So if we remove that and we run this again, and actually what I could technically do is I can just say make lint, and we no longer have our errors there. They are no longer present, which is good. I'm curious what these are, but I think this one should be required. I don't know why I didn't put that at the top here. Every YAML file has to have this 3 lines at the top. It's a best practice. So I'm going to put that. I'll come back to this later. I wouldn't worry too much about this. Okay, so finally, the very last thing we are going to cover. Actually, no, before we cover that, there's 2 other little things I want to mention. I showed you no QA. No QA excludes a line of code from Flake8. Another thing you can do is you can have a .flake8 file. In the .flake8 file, there's certain standards that you can ignore from Flake8 that it won't inspect for. It won't inspect for certain things. The max line length is just basically a best practice. So it'll throw an error if a line is greater than 88 in length. And then finally, the exclude, which is also important. I want to exclude certain code. For example, I want to exclude tests. I want to exclude my virtual environment. I don't want to go through the whole virtual environment and lint through code that is not mine. Okay? And then I got a couple other things here which I have for one reason or another. I wouldn't worry too much about those. But if you want to basically adjust what you inspect in Flake8, this is how you do it. You determine all the standards, and the way I did this, you're probably wondering, how did I know which ones to exclude? Well, whenever I get the log errors of which ones pop up, some of these I don't need to worry about. Some of these I don't want. I don't need them. They're for specific situations. So that's why I excluded those. And then line length, that's just a best practice. Excludes, again, it just has to do with not inspecting code I don't want. And then the other thing is for black, you can use a pyproject.toml file. And what I do here is I also want to exclude all those folders or files that should not be linted, or excuse me, that should not be formatted. These are some of the common boilerplate folders that I don't want to format. So based on that, I just add them to this list. And again, line length 88. So it's going to adapt to this specific line length. It's going to format it based on that line length. Okay? So that's what this file is for. Finally, we are going to check out Bandit. Bandit is a security testing module. And Bandit also has a file you can configure. I want to exclude certain folders, and I also want to determine certain tests. Now for this is not the same as PEP8. These are not, these can be determined if you go to Bandit help. It'll give you every single one here. So I just put a set of based on the ones that I wanted, and then I put it in this file, and you just format the file in that regard. And then I'm going to redirect this to a output file. And we're just going to say text. Okay. And I just did its thing. So now I'm going to go to the Bandit file, outbandit.txt, which we have 2 of these now. I want to delete both of these. And you will see here that we have two specific issues. Firstly, we have a hard-coded password default. So it actually detected in the code, it detected a password that is embedded. Okay. This is just a default login when the devices are first reached. So I'm not really too worried about this. We can ignore this. The second one though, I didn't know this is a thing, but apparently there's something called YAML.safeload, and I'm not sure what the differences are. But as you can see here, it says use of unsafe YAML load allows instantiation of arbitrary objects. And then it tells you what the solution is. So this is really nice if you're trying to tailor your code to some very security conscious client. With this, all you have to do is look at what is the reason this code is problematic, what is the solution. And then it'll also tell you how much code was scanned, also what are our total issues by severity and by confidence. Okay, so there you go. That was in total 4 tools. In total, 1, 2, 3, 4. Use all of them. They are all fantastic tools. Right? If you like this video, subscribe, share the video, get the word out. And if you want to know more about the efficient way of going about your day, the efficient way of going about your projects, of going about systemizing how you do certain things. It can be in tech, it can be in whatever. Check out the website, subscribe to the newsletter as well. All right? Thanks a lot, guys.